All right, some more terminology. A or B. A or B means that an outcome is in event A or is in event B or in events A and B at the same time. So let's look at an example. All possible outcomes for rolling a fair six-sided die are 1, 2, 3, 4, 5, 6. Let A equal rolling a 2, 3, or 4. B equal rolling a 4 or 5. So the answer for A or B is everything in A, everything in B, and everything that is in both of them. So we don't rewrite any numbers. We don't repeat them. We write 2, 3, 4, 5. A and B means that an outcome is in both events, A and B, at the same time. So an example, if we're looking at the fair six-sided die, if A equals rolling a 2, 3, or 4, and B is rolling a 4 or 5, we're looking where they overlap, where they intersect. So A and B is 4, because 4 is in both A and B. The last two pieces of terminology we need to go over. The first one is the complement. The complement of event A is read A prime. They're all outcomes in the sample space that are not in A. So let's look at an example. All possible outcomes for rolling a fair six-sided die are 1, 2, 3, 4, 5, 6. If A is 1, 2, 3, and 5, then A prime would be whatever isn't in A, so it's 4 and 6. When you add those two together, when you add the event and the complement of the event, you should get an answer of 1. They should total 1 because you're adding what's in one event and then what's not in it. And that should be the total. Conditional probability. The conditional probability of A, knowing that B has already occurred, is written this way. The probability of A given B. We write it this way with that line in between the A and the B. So we are looking at the probability of A given that B has already occurred. Let's calculate the probability of A from the sample space of B. In this example, all possible outcomes for rolling a fair six-sided die, 1, 2, 3, 4, 5, 6. If B equals 1, 3, 5, and 6, and A is 1 and 3, what is the probability of A given B? Okay, B has already occurred, so the formula to calculate the probability of A given B is the probability of A and B, okay, it's where they intersect, what they have in common, divided by the probability of B. So we're going to do this by first finding the probability of A and B. A and B, where do they cross intersect? Well, 1 and 3. So the probability of A and B is 2. There are 2 that they have in common out of a total of 6. So 2/6 right here. Divided by the probability of B. So B has 1, 2, 3, 4 out of a total of 6. So when you do that, the answer is 2 over 4, or we could reduce that to 0.5. So the probability of A given B is 0.5 or 50%.